is, at the end of the day, there are a lot of packets in the network, and those packets need to be delivered to security tools in order for them to do their analysis and do threat hunting and threat detection, threat identification. And traditionally, what happens is you go to the production network and either put a tap or a span, do a span session and get the mirrored data out and send it to the tools. Now, as you expand the tapping and spanning across your environment, you have more and more links, and hence you need a network to aggregate those links, tap and span links, and then send the right type of data, specific data, interesting data to the tools that have interest in that data. And there are multiple use cases, security being, kind of a top use case. And in fact, that was the genesis for, network packet broker being born to aggregate tap and span traffic and filter it and send it to the tools. But, more and more, we are, of course, seeing NetOps tools, network performance monitoring, application performance monitoring, also leveraging the same infrastructure. Today, obviously, we will talk about the role of the network packet broker, kind of, the traditional way the security tools have received packets, and see what are some of the innovations that need to occur or have been occurring to assist this whole environment of zero trust security, zero trust networking. The fundamental to this is, if you can't see, you can't secure. So you got to see in order to see the packets, in order to secure them. And one of the challenge, of course, the production network is always, multi-vendor. You have many endpoints, users, devices. You have applications. But as we think about zero trust, we are saying, I want to secure everything, secure pervasively, and therefore I got to be able to see pervasively, right? And pervasively means I got to see across multiple domains, whether it's campus, whether it's edges, internet edge, WAN edge, multi-data center environments, data centers, colos, branches, right? So variety of network locations from which traffic needs to be extracted, and then part of that be sent to the security tool. So the question is, how do we architect an NPV so that it can be a game changer for zero trust? I mean, we can't be taking, our father's Oldsmobile and applying it to the new decade where zero trust is going to be mainstream. So bringing modernity to network packet broker is very important. So let's kind of play a role of a customer who is going to initiate an RFP and a product manager who is going to define the product that we want to build, right? So what are some of the requirements for zero trust? So let's start with first one, very obvious one. You got to have pervasive access to network traffic across, variety of locations in the data center, colos, edges, branches, campus, and so on. Of course, you want to capture north-south traffic, you want to capture east-west traffic, and all sorts of endpoints are generating this traffic, app to app, user to app, device to user, and so on. So that's number one requirement. Let's look at a second requirement. Mission critical monitoring. If you start dropping packets in the packet broker, then you might be losing important information, or security tools might not be, getting the right fidelity of the data. So how do we minimize the packet drops during traffic bursts? Remember, this has been an important consideration for applications in data center in the production environment. But now this requirement is also getting extended to packet brokers because of this mission critical security and threat identification needs. The third, which is stated here as network time machine, but very specifically, how do we rewind the network state? When incidences occur, we want to go back and replay that incident, see how that threat has been manifesting, or that, if we are hunting for threats, we need to go to various different sources to be able to extract the information. And so ability to rewind and replay the network state becomes very important. And finally, how can we automate this? We have seen automation in DevOps. Then we have seen automation in net DevOps. And the same automation principles are being applied to SecDevOps. So security teams and security workflows, if they're automated, then we can do the threat hunting and threat identification faster. And so these are sort of new requirements driven by zero trust on the network packet broker. And the question is, how do we, bring this about into a modern NPV? And so let's start with a very, generic version of an enterprise environment. You have the data center, you have the edges, you have campus and branch locations. Gary showed a fairly sophisticated diagram here. I'll start with a simpler one, just so that for conceptual reasons here. And then we have a network packet broker with a couple of switches. And how do we build one that provides pervasive access? When we say pervasive, there are multiple things that need to happen. The first one is going to be scale out, because we are going to be touching more and more part of the production network, that more links, tap links, span links are going to be coming to the packet broker. So the packet broker has to be a scale out entity. How do we build a scale out packet broker? Well, our hints are really from the production network. How have we built scale out networks in data center? We have used leaf spine architectures. Why can't we apply the same to the packet broker? And that's really the clue that can be leveraged and extended into the packet broker. So here, some tap links, typically edges and core routers get tapped. They're brought into the network packet broker. Now, because of cost reasons in the data center, one of the popular way to mirror traffic is through spans. So a couple of span sessions are available on every switch. So you start with top of rack switches, take their uplinks, span them. These are either 40 gig uplinks or 100 gig uplinks, and bring it to the packet broker. You run out of ports in the packet broker switch, no problem. Add another quote unquote leaf monitoring switch and aggregate the traffic. You have more racks coming in the data center, or more tools coming to your environment to monitor more, not a problem. On the egress, add another switch and continue to build this structured topology. You have more racks coming in, add more switches at the egress. If you have campus locations, branch locations that are kind of remote, not a problem. One can extend the packet broker environment all the way to the remote location and then haul the traffic back into the mothership through tunneling, such as L2GRE links. So now we have really addressed the first requirement, which is, how do we build a scale out architecture? Next is going to be, how do we make it optimal from operations perspective? Because, as we know, teams are not growing. They have to do more with the same. And so OpEx simplicity or operational simplicity is kind of the name of the game. And so one way to do that is to have software intelligence, in the form of controllers, to be able to manage that entire packet broker structure or architecture, the entire leaf spine architecture of dozens of switches. And I didn't talk about, maybe I should go back. There are also packet modification systems, which we call service nodes here, that can do deduplication, header stripping. It can also do packet slicing, netflow generation, IPFix generation. So all of that, all of those devices are operating, as part of one logical NPV. Now, why is this OpEx simple? It's because dozens of devices operate as if they're logically one device. And so from an operations perspective, you're managing one device. You're writing policy from ingress to egress without really thinking about the number of devices or hops that are in between. Operationally, it's all zero touch management. So no box by box management or policy provisioning. The third is, if you're going to do pervasive monitoring, then we are going to have a lot of boxes, a lot of devices. There's a cost equation to that, and we want to make sure that we don't break the bank. And so CapEx optimization becomes very important. And here we use tried and true approach, which is leverage merchant silicon, not custom proprietary, scale up hardware, but merchant silicon switches and x86 servers. So very standard, industry standard hardware, very cost optimized that is deployed or is deployable to build the scale out architecture that is managed as if it's one logical entity, not box by box. So these three conditions or capabilities, get us to delivering pervasive access to traffic that can be sent to a variety of security tools for SecOps needs. Now, let's go to the next requirement, mission critical monitoring. How do we address this? Well, for this, we need to have, there's a tried and true method in the production data centers, use deep buffer switches. Merchant silicons are available to do deep buffer switching, and these are from Broadcom Jericho family of ASICs. And interestingly, Arista has a large family of switches that are built with the Jericho ASIC, all the way from 10 gig, 25 gig, 100 gig, 400 gig, variety of port density. And so leveraging deep buffer switches, certain customers who need mission critical monitoring, we have seen that need in financials, we have seen that need in federal defense intelligence environment, where such deep buffer switches can be deployed, and one can build a network packet broker very uniquely. I mean, this is a very unique offering for the network packet broker, through Arista on DMF to really minimize the packet loss. And now we have seen even some customers in other industry verticals to say that, maybe the front end switches I'll use standard, Trident and Tomahawk switches, not Jericho, not deep buffer switches, but I'll use the switches that connect to my tools, my security tools. That's where the concentration of traffic happens, and I'll use deep buffer switches there. So regardless of that, there is obviously hybrid approach is possible and available, but it's important to have in one's portfolio deep buffer switches. Now let's look at the third requirement. How do I, get the network time machine effect, rewind and replay the network traffic? Well, I mean, fundamentally, in order to do that, you got to record the traffic. If you are going to record the traffic, you need to have a device that does the recording, which we call a packet recorder or traffic recorder. Well, what one can do is to extend the NPB's functionality. Think of it as NPB++, which is sucking in the tool's functionality. In other words, have a recorder node that is also part of the NPB architecture or NPB solution, and it is managed by the same controllers. So logically, you still have the one logical operational entity that you're managing, but now you're delivering multiple different functionalities in order to enable zero trust. So recorder nodes can be now part of our architecture, the extended modern NPB architecture. And what does it deliver? Well, with recorder node, we can, obviously storing packets to deliver PCAPs to the tools that need them. We can also replay traffic exactly the way it was captured to the tools, so that the tool can actually, play it and see how potentially a threat was evolving and was jumping from one place to another and so on. Of course, recorder node can provide additional network visibility functions such as application identification, TCP analysis and other things. But certainly for security purposes, PCAP and replay become very important. How do we automate SecOps and SecOps workflows? So here, today, I mean, we are 2022. No vendor is going to say that, I'm not delivering APIs. Everybody's saying I'm delivering APIs. So what is it unique that we can do, value add that we can do that is beneficial to the customers? So first, can we concentrate all the APIs through the controller as a single point of API interface, right? It's a single point for operational and management. Why can't it be one point, single point for APIs? And that's exactly the case here. DMF controller is the single point of API interface. And so a SecDevOps team can now, talk to the security tools that provide APIs, talk to DMF controller, and be able to automate their workflows. Now, is that all we can do, or can we do better? Can we assist the SecDevOps team in creating their scripts very quickly without errors? And so what we have done is, what is this API first principle? To me, API first principle is really, when you have a CLI, it should be using the same APIs. When you're doing GUI workflows, it should be using the same APIs. So API is kind of the fundamental substrate to everything that you do, and then CLI and GUI become the client of it. So every time you test CLI and GUI, you have a complete representation of APIs, and there is no impedance mismatch between these systems. So once you have that, you can say, okay, turn on the, show me the APIs. And here's an example. We have a command called debug REST, which shows all the REST commands. And then as soon as you start typing CLIs, it prints the REST commands. Now, all one has to do is copy these REST commands and put it in your automation scripts, and you're good to go, because you know exactly what it means, because you use the CLI workflow or the GUI workflow, and those APIs have been extracted from that. So very simple. No one has to go through hundreds of pages of API documentation to be able to do this. You just do cut and paste and you're good to go. Now, can we do even better? Why can't we actually, have certain workflows which we know are very important to end users and build them into our products directly? And this is exactly what we have done with the Awake NDR and DMF. You heard NDR sensor component has disk space and it stores PCAP. But if one is looking at zero trust and kind of enterprise wide, you may have to get traffic of the past from other parts of the network. And how do I do that? Well, once recorder nodes are deployed in the environment as part of the DMF deployment, NDR can request through the DMF controller to get appropriate PCAP that it doesn't have. And this is an integration that is built today. And you can see that the Awake or NDR GUI, once it connects to the DMF controller, now you can request PCAP, assuming that data is recorded on the recorder node. So we see, these type of integrations as part of, what Rudolph called DFX solution or DANZ forensics exchange, where it's not just components that are working better together, but the components that are integrated so that workflows are automated, and one is able, our security operations team is able to get to the answers faster as they are doing investigation and chasing threats.
So often I have stumbled across the problem in data centers where you have a lot of traffic, let's say 200 gigs, that a single recorder cannot take that load. Yeah. How is it scaling for, let's say, high load traffic conditions? What can each recorder take when it comes to traffic load, and how can you scale them up?
Yeah, absolutely. So I will kind of answer it architecturally, and for each of the device, we provide a full kind of scale tested document in terms of exact speed of recording, the amount of traffic you can record at different packet lengths and so on. But architecturally, the solution to this is clustering. And so every device that is provided, so switches are defined in a leaf spine manner. So that's kind of the clustering for scale out for the switching portion. But for the appliances such as service node or a recorder node or analytics node that I haven't yet talked about, these are part of the DMF architecture, and they are x86 based appliances, and they are built with clustering in mind. So you start with one. As you add more, they just become a bigger and bigger cluster with higher bandwidth and higher capacity for storage. But from management perspective, it appears as if it's one cluster, part of that one logical NPV. So the entire architecture is scale out, and the way we scale out recorder nodes is by just adding more nodes that automatically cluster with themselves. So when you initiate a query from the controller that I would like to get this PCAP, you don't have to know which recorder node you're going to. The controller will figure out, the machine will figure out where the traffic is, and it'll extract the traffic and deliver the PCAP. So externally, it just looks like one big logical recorder, but obviously it is built with multiple discrete devices. There are many parts of the network where all you can do is some basic capabilities, NetFlow collection and analysis, and that's what really analytics node does. It is yet another node in the DMF architecture where you can get additional visibility that is helpful to security. Flow analytics, it's built in. It's a flow collector, large scale flow collector. You can get compliances. You can identify rogue DHCP, DNS servers, and things of that nature. So it enhances, security by providing additional visibility to a broader set of traffic and locations that you have. Now, folks who would like to try it out online, in the convenience of your living room or kitchen, you can sign up. The link is there. And there are a variety of modules available that you can try and get the feel for this modern, NPV that we believe is ideally suited for Zero Trust.